Hello all, today we'll be discussing about the maths intuition behind a regression problem statement. In my previous videos, I've already shown a lot of practical application and examples with respect to simple linear regression and multiple linear regression. But in this particular video, I'm going to describe or discuss about the detailed explanation on the maths of the regression part. So everybody remembers that the linear regression or the simple linear regression or multiple linear regression is basically given by the equation y is equal to mx plus c. And this is basically my best fit line. By using this equation, I actually try to find out the best fit line. Over here, my m is basically the slope, right? And c is basically the intercept. Let me just discuss about this first. What does this basically mean? Suppose I have a problem statement saying that with respect to the size of the house, I have some prices in my data set. So some of the points will be somewhere populated like this, and what we are actually considering or what we are trying to implement by using a regression algorithm is basically that we'll try to create a best fit line such that this best fit line, it will indicate that for my future size, suppose for this particular size, I want to find out what may be the price of the particular house. Then what I can do is that I can actually point to this particular point over here and I can try and find out the price value, and I'll be able to determine the price with the help of this best fit line. So this is my best fit line. And as discussed, this best fit line is basically indicated by the equation y is equal to mx plus c. Now, what does this component mean? That is my m value and my c value. Guys, always remember, whenever your size is 0 and your price is 0, right? Or whenever your size is 0, right? Not price is 0. I'll just cut this. Okay. Whenever your size is 0. Now over here, when I consider this size, I am basically considering that my x value is 0. So this, from this equation, if my x value is 0. So if my x value is 0, if I equate in this particular equation, my y will basically be c. So my y will basically be the c, which is the constant or the intercept. And this basically indicates that when my size is 0 at this particular point, where does my price actually point to the y-axis? Okay, so this particular point in this particular equation is basically my c, which is my intercept. So when my size is 0, and what is the point that I have in the y-axis for the price, that is the point that is called as c. The other thing that I want to discuss is about m. This m basically indicates that, suppose over here I have something like 1,000 square. Okay, 1,000 square meter, 1,000 square feet, and here I have suppose 1,100 square feet, right? Now, within this unit change, suppose if I'm considering that 100 meter is my unit change in my x-axis, within this unit change, what is the change in your best fit value? What is the change of the price? That we are actually considering it as a slope. So this particular slope is basically indicating that with the unit change in my x-axis, that means my size, what will be the change in your y-axis, and that is what we are trying to find out. Now, now the other way that you may be thinking that how can we think of a best fit line, in this particular equation. See, one way is that I can draw multiple best fit line, multiple best fit line like this. And what I should try to do is that I should try to minimize this distance, minimize this particular distance or this particular error, such that if I do the summation of all the error, it should be minimal, right? It should be minimal. So this particular error, we should try to find out the summation of all the error, and whichever best fit line gives us the minimal error, that value will basically indicate or give me the slope value, that is m, and some value as c, which will be my intercept. Now again, I'll just clear this diagram and just try to explain you properly. Now you see this. Oops, sorry. Now suppose I have this, okay. I have this x and y value. Suppose my x is basically my size and y is basically my price, and I have a lot of points that is getting populated, Now from this, I found out that best fit line is this one, okay. Now what we should consider while selecting the best fit line, I will define a function which is called as cost function. Again, guys, this cost function is very, very important. See, this cost function is also a basic thing that we'll also be learning in deep learning. So it is very important to understand this. So make sure that you watch this particular video till the end. So now this cost function can basically be indicated that, as we said, that the distance between the best fit point, that is this, and my real point should be minimal. So I can write an equation saying as 1 by 2m. M basically means that it is the number of points, all the points, with respect to the x and y axis. 1 by 2m, I'll say summation of I is equal to 1 by m, 1 to m, and then I will write it as y hat minus y whole square. And this is what I'm going to write it down. Now, you know that my y hat will basically be indicated by y is equal to mx plus c. This points that I have over here, right? This is basically my y hat. This is my y hat. The points that you find out or that you predict in a best fit line is basically your y hat. And this y basically indicates the real points. It indicates the real points. So we should try to minimize this error. And while minimizing, whichever best fit line gives you the minimum error, that is selected as the best fit line. But now the next question rises that just by using this equation, how do I find out the best fit line? Because I can have multiple best fit lines, right? I can have a lot of best fit lines, and then from that I have to compute all the summation and then try to find out what is the minimal value. That will not exactly work. That will actually take more amount of time, and which will unnecessarily waste your amount of processing power and amount of processing itself. We can't just select million number of lines and try to find out the cost function. Instead, I'll just show you a more efficient way. So to begin with, I'm going to give you an example again. So suppose I am considering x and y. Okay, so this is my x, okay, and this is my y. And suppose this values I have like 1, 2, 3, and 4, right? And similarly, I have over here 1, 2, 3, 4. Now suppose let me consider some points over here. Suppose my first point, my y point is basically when my x value is 1, my y value is also 1. So I'll draw my first point over here. My x value is 2, my y value will also be 2. My second point, my x value is 3, my y value will also be 3. Suppose these are my 3 points, okay? And now this is my data. This is my real data, okay? And this real data is basically given by the equation y is equal to x, because when I'm saying my x value is 1, my y value is 1. Now the next thing is that I need to find out my best fit line, for this particular point. So I'll write the equation as y is equal to mx plus c, okay? Now let me consider that my c value is 0, okay? The reason why I'm telling c value is 0, because I'll try to find out a best fit line through this particular points, and I'll consider that c value passes through the origin. The origin, when my x value is 0, my y value will be 0, right? And again, there is a reason why I'm making it as c is equal to 0, because I'm going to draw a diagram over here, which if I make c is equal to 0, then I will be able to draw a 2D diagram. If not, if I consider c is equal to with some other value, then I have to basically draw a 3D diagram. And for a 3D diagrams, it will definitely be very difficult for me to draw it over here. Okay, so I'm considering the c value as 0, indicating that it passes through the origin. Okay, when my x value is 0 and my y value is 0. So when I make the c value as 0, my new equation is something like y is equal to mx. Now this y hat is basically indicating my best fit line. So for x is equal to 1, let me equate x is equal to 1 and try to find out my y hat value. And let me consider that my m slope, initially I'm just initializing my m as 1. Okay, so when my m is 1, so let me just equate it over here. Okay, so when my m is 1, so this basically indicates that my y hat is basically 1 multiplied by 1. Now let me just write it in a lighter format. So y hat will be actually 1, right? So my first point after 0, my best fit line will pass through this y hat. Okay, so this particular point also has y hat, and this particular point also has y. Now for my x is equal to 2, what will be my y hat? You know that my slope is 1 and my x value is 2, so it will be 2. So then again this line gets extended and gets passed through this particular point. Similarly, y hat, when my value is 1 and my x value is 3, because my x value is 3 and this particular point is 3, then again my y hat will actually be 3, so it will pass through this particular point. Now this is what my best fit line is. My best fit line. for this particular value when my slope is 1, when my m value is 1. Very important. Now, after I get this particular equation, I will basically find my cost function. Guys, remember, I have already discussed about the cost function, and the formula is something like 1 by 2m summation of 1 to m y hat minus y whole square. So this particular value, I have to reduce it, you know, I have to find out this error and try to reduce it. Sorry. Now what I'm going to do is that I'm going to equate this, and suppose for the summation, first of all, when my x value was 1, my x value was 1. What was y hat? Y hat was 1. So I'll write it as 1 minus, what was my y value when x is 1? The real y value is 1. So I'll write 1 minus 1 whole square plus, then when my x is 2, my y hat was 2. So this will be 2 minus 2 whole square plus 3 minus 3 whole square. So when I equate all these things, obviously my m value is 3 points. So m is actually 3, you know. So 1 by 6 multiplied by 0 is nothing but 0. Okay. So now this is very, very clear. When my m value, when my slope was 1, you know, and for this point, I got the cost function as 0. So what I'll do is that I will try to draw one more diagram. And this is the most important diagram, guys. Please do focus into this. So here it is. I'm having 0.5, 1, 1.5, 2.0, 2.5, right? And suppose this y-axis basically indicates my cost function. My cost function, suppose I write it as j of some m value, slope, okay? And my here, my slope is basically my m value. And here also I will write it as 0.5, 1, 1.5, 2. Now what I'm trying to do is that, everybody please focus into this. What I'm trying to do it in this particular thing is that with respect to every m value that I have initialized, what is the cost function that I have got? I'm going to plot it over here. Now initially here, with respect to the m value as 1, you know, I have got my cost function as 0. So what I'm going to do, my m value is 1 over here, my cost function is 0. So this is the point that I'm going to get. I hope it is pretty clear. Now in my next step, what I'll do, I'll change this m value. Suppose I take my m value as 0.5. Okay. Now with respect to m is equal to 0.5, for this equation, if I equate, okay, my y hat for x is equal to 1 will be 0.5. My y hat for x is equal to 2 will be 1. And my y hat for x is equal to 3 will be 1.5. See how I'm getting this, guys? You just have to equate this. See, when my slope is 0.5, when my x is 1, 0.5 into 1, 0.5, right? My y hat is 1, 1 into 1, 1. Then when my slope is 0.5 and my x value is 3, you know, 3 into 0.5 is 1.5. So I will be getting new points somewhere like this, 1, 2, and 3. So this is my, this is my 1.5. So when I draw my best fit line, it will look like this, you know. Now when I try to find out the cost function, when my m value is 0.5, you know, I will be getting, you just have to equate in this. It will be 1 by 2m summation of I is equal to 1 by m, and it will be nothing but, suppose for x is equal to 1, my y hat was actually 0.5. 0.5 minus what was my y? It was 1 whole square plus, similarly you'll do it for 1 minus 2 whole square plus 1.5 minus 3 whole square. So you just equate in this particular equation, place the m value as 3, and m basically means over here m is nothing but, or you can just write it as n if you are getting confused. Okay, so n is basically the number of points. Okay, and if you compute this, you will be getting somewhere around 0.58. Now when I say 0.58, you know, this is your cost function. When your m is 0.5, your cost function is 0.58. So here you can see when your m is 0.5, your cost function is 0.58. So it will be coming somewhere here. Your next point will be coming somewhere here. You know, then similarly for different m values, you know, you will be getting points which will form this kind of curvature. This kind of curvature for different m values, you know. And when you draw this, you will be getting a diagram which looks somewhere like this. And this is basically called as a gradient descent. Now this gradient descent plays a very important role, guys, which I'm going to explain you in the next screen. Now, once you get this gradient descent, when should you know that you should stop, for selecting a M value which looks good for this regression line or for the best fit line? That is the next thing that I'm going to discuss. So before that, I'm going to clear all this diagram and let me just focus on two things. One is the gradient descent. As I said that this is my M value, this is my cost function, that is J of M. And here I'll write it as 0.5, 1, 2, sorry, 1.5, 2, 2.5, right? Similarly, here I'll write it as 0.5, 1, 2, 2.5, 3. Okay. And you can see that my graphs look something like this. Oops. Just a second. Okay, so my graphs look something like this. Suppose I'm getting this point somewhere populated like this, and this point populated like this. I'm just going to draw my gradient descent. Again, it may not be approximately correct, but it may not be approximately correct, but I'm just trying to draw this diagram properly for you. Okay, so here it is. I'm going to draw this, which looks like this, and which looks somewhere like this. Okay, guys, so this is basically my gradient descent, which I have drawn again. I'll write it as gradient descent. Now, in my previous diagrams that I've already shown you that based on different M values, we're getting different points. And finally, we could follow this particular structure. But the next thing is that how do we arrive to this particular region? And this region is basically called as global minima. Global minima. Now, the next thing is that I need to arrive at this particular position. So for that, initially, suppose I consider that based on some M value, I got my initial point somewhere over here, somewhere over here. So when I get my initial point over here, that basically means that I have to move downwards, right? So in order to move downwards, I will basically write a theorem which is called as Convergence Theorem. Now, for this Convergence Theorem basically says that the M value you should subtract with M minus derivative of M, derivative of M with respect to M, derivative of M with respect to M, such that, this derivative multiplied by one more value which is called as learning rate, which is basically indicated by alpha. So this is my learning rate. Okay, now let me just show you why this particular equation works. Okay, now suppose initially, and this derivative is basically my slope. Okay, this derivative is basically my slope. Okay, now let me just tell you. Now suppose for some M value I got to this particular point or at particular this position, and then I'll be applying my convergence theorem. Now convergence theorem basically says that I have to subtract with the slope of this particular point. So if I want to find out the slope, you just have to draw a straight line like this. Okay, and this particular straight line is basically helping you to find out the derivative of the slope. When I draw this particular slope, the next thing I have to find out whether this is a positive slope or a negative slope. That is important to find out. Now, how to find out whether this is positive or negative? Now, you should see or focus on the right hand of the slope and the left hand of the slope. If the right side or the right hand of the slope is pointing downwards, is pointing downwards, at that time you can say that this is basically a negative slope, the negative slope. Now you can see that at this particular point, suppose my M value was somewhere like minus 0.5. Okay, then your feasible M value is somewhere around 1. Now when you find out your negative value, this particular point value is having a negative slope, what you do is that you subtract M with some, and whenever you do a negative slope derivative, you will be getting a negative value. Okay, and this alpha or learning rate will be a smaller value. I'll tell you why we have to select this as a smaller value. When I say smaller value, then this value can be somewhere like 0.001. Okay, so when I take a negative slope, okay, when I find out the derivative of a negative slope, then it will be a negative value, and which will be a very minimal or small value. Okay, now when I do like this, I'll just write it as M plus some positive value, or smaller positive value. Okay, because see, minus into minus is plus, right? So plus positive smaller value, because this is a smaller value of learning rate. So what will happen is that basically indicates my m value should increase from minus 0.5 and it should come nearer to 1. So this step will be very, very small. You know, it will be very, very small. And as iterations and different m values get selected, this will be moving towards this particular global minima point. Now, the next thing is that if I select this learning rate as a larger value like 1, okay, 1.00, what will happen is that instead of taking this smaller step, this point may jump to some other points like this. Okay, this may take a longer jump and it may not reach this global minimum even after many iterations. Even after many iterations, it may not reach this global minimum. So for that reason, we usually select the learning rate value as a very smaller value, you know. And okay, let me just consider that suppose for my suppose I selected a random m value and I got the point somewhere here. Okay, somewhere here. Suppose I got it somewhere here. Now you should see that when I get this point over here, if I try to find out the slope of this particular point or the derivative of this particular point, I'll see that my right hand side is pointing upwards and my left hand side is pointing downwards. So this is basically my positive slope. And when I try to find out a derivative of a positive slope, this basically indicates that my derivative will be nothing but m minus, this derivative will basically be a positive value. And then I'm going to multiply with my learning rate, then which will be nothing but m minus some smaller value. When I do m minus smaller value, then you can see that initially, suppose my m value was 2, I have to reach it to 1. So it will subtract a smaller value and we will be moving in this particular position. So always it is very important to understand that our learning rate should be very, very small. And this convergence theorem is very, very important to reach this particular global minima point. So as soon as it reaches over here, at this particular point, if I try to find out the slope will be 0. The slope will be 0. And when I have a slope is 0, that time my m value will specify that this should be the value or this should be the slope of the best fit point, best fit line. Until then, I have to follow this convergence theorem. So once I get to this particular point at this particular location when my slope is 0, I will basically, or my algorithm will basically be considering this m value as my best fit, as the slope of the best fit line. And that is the point where I have to stop training, and that is the point which will be able to determine that is the value of my best fit line. You know, and this basically indicates the whole explanation, the theoretical concepts along with maths of the whole linear regression algorithm. Now the next thing is that if I have multiple features in, suppose if I don't just have only one independent feature, I have multiple independent features. At that particular point of time, my gradient descent will look like a 3D diagram or a 4D diagram based on the number of features. And each and every feature will try to move towards the global minima point, which will be this particular minima point. I hope you like this particular discussion, guys. I hope you liked the step-by-step process and how we derived it. Please go through this video from once again from the starting. And now, after understanding this thing, how do you implement it? I'll be providing the link. You can see in the top right corner, I'll be attaching a link, and there you can actually see the implementation part of simple linear regression and multiple linear regression. I hope you like this particular video. Please do subscribe to the channel if you have not subscribed. And yes, I'll be coming up again with some new good videos where I'll be discussing all about this mathematical combinations, and I'll try to derive all the things in front of you. Okay. So God bless you all. Keep learning. You're doing a great job. And thank you for supporting my channel. Thank you one and all. Have a great day ahead.